Hi class. In this lesson, we are going to be working on solving capacity problems. And what that means is we are going to take what we know about capacity, what we learned in yesterday's lesson, lesson 6, and add it to what we know about solving word problems. So what you're going to need to get started is your sharp pencil and your math packet. We're going to be using pages 639 through 644. Please get those things now. Remember, when we solve word problems, we want to be on the lookout for 3 very important things. The first thing we want to look for is the numbers that we're going to be working with. Back when we were working on word problems earlier in the year, I taught you to go and circle the numbers that you see. These will help make sure that they don't get lost and we don't overlook them. The second thing you want to do is you want to find your label. Your label is what's going to go with your answer on the line. It tells us how much of something we have. The thing I always say in class, if you don't give me a label, it's monkeys. I don't think monkeys are going to fit very well with capacity. The last thing we need is to look for key words in our word problems. So that means we're looking for words like together, which would tell us that we're adding. If it uses the word divide, it means we're dividing. We can find all of these things by carefully looking at our problems. Let's start by looking at problem example 1. I'm going to read it. You please follow along on your page. It says, Emily used 240 milliliters of lemon juice and 960 milliliters of water to make lemonade. How many milliliters of lemonade will she make? Go through and circle the numbers that you see in this problem now. Also, I want you to underline our label. What's our answer going to be in? The numbers that you should have found are 240 and 960. And our label for the problem is going to be milliliters. That's what we're talking about. The book is pretty good in giving us the steps that it wants us to take. It has shown us that we're adding 240 plus 960. Now, I know I told you to look for keywords. If we go back and look at the way that this word problem is written, though, there aren't keywords that tell us to add. There's nothing that says together. It does say how many, but how many can be for any of the 4 operations. This is when we have to use our brains. We think about what's the problem asking us to do. Emily's making lemonade. She has water. She has lemon juice. If we want to make lemonade, do we subtract? Do we divide those things up? We're adding them. We're putting them together into one pitcher, mixing them so we can have lemonade. If you add those 2 numbers together, you should get 1,200 milliliters. Do this problem in the blank space beside the word problem now. Let's do example 2 together. Follow along as I read out loud. The total capacity of 8 pitchers is 24 liters. What is the capacity of each pitcher if it has an equal amount of lemonade? Write an equation with a symbol for the unknown, then solve. Take a look at the word problem. Circle the numbers that you see and underline your label. You should have circled the numbers 8, 24, and underlined the word liters. Liters is the unit that is our label. Notice how underneath the word problem, they have written find the unknown, and they actually give us the equation that we need to use. 24 divided by 8 equals blank. They have a little gray square there. We like to use question marks or even just a straight line is fine. Now, they gave us the equation. They told us that it's 24 divided by 8. But let's look back at the problem to find out why are we dividing? The total capacity of 8 pitchers is 24 liters. What is the capacity of each pitcher if each has an equal amount of lemonade? When we have an equal amount, we're dividing the total amount into each group. It doesn't actually say the word divide, but it does say an equal amount. Think if you and a couple of friends were sharing some kind of snack and everybody wanted an equal amount. You would be passing them out to each person, so each person got an equal amount. This is exactly what we're doing when we're dividing. There are 24 divided by 8, or 3 liters in each of the pitchers. The unknown is 3. And below that they've written, use the inverse operation to check. That means they want you to do the opposite, or multiply, to find your answer. Is it true that 8 times 3 is 24? Yes, it is. We did the problem correctly. Turn to example 3 on the next page. Follow along as I read out loud. Dylan is helping his dad wash the car. Attaway, Dylan. His dad filled up 2 buckets with soapy water and 2 buckets with clean water. The capacity of each bucket is 9 liters. What is the total capacity of the 4 buckets? If we circle every number in this problem, we're going to be in trouble. We would be circling 2, 2, 9, and 4. The word problem only wants us to do one step. They drew us a picture. Let's look at what the picture shows. If I count the number of buckets in this picture, I see that the total number of buckets is 1, 2, 3, 4. I see that 2 of them have bubbles coming out. Those must be the 2 with soap. How many liters is the capacity of each bucket? Let's go back and check in our problem. Oh, I see that it says the capacity of each bucket is 9 liters. Do you notice the white square in the middle of each blue bucket? Let's write 9 in each of those buckets. So we'll have 9, 9, 9, and 9. There's 2 ways that we could solve this. One is we could use repeated addition. To find the total number of liters, we could add 9 plus 9 plus 9 plus 9. Or we know that the faster way of doing repeated addition is multiplying, which they have written for us here. It says find 4 times 9. 4 times 9, 36. There are 36 liters of water in the buckets. Friends, if you're working through the problems in the homework or the independent practice section and you find that you're having a hard time visualizing what these problems look like, please draw it out. I, of course, didn't send home any pages for you to do DEAL, draw, equation, answer, and label, but you know it well enough to be able to write it maybe on a piece of paper or even in your book. Use pictures if you need them. The last one we are going to do together is under guided practice number 1. This is a different type of problem, and I want to make sure that you feel comfortable with it before trying it on your own. Find number 1 in your book and follow along as I read it out loud. The directions say, write an equation with a symbol for the unknown, then solve. So we're going to write an equation. We know how to do that. Number 1, find the total capacity of the liquid shown in the containers below. The word total. When we hear the word total, it means we're bringing everything together. We want the total amount. We must be adding. Let's keep that in mind as we look at these 2 containers. I'm starting by looking at the first container on the left. Oh, this reminds me of the work that we did yesterday. Remember how we read the amount of water in containers? That's exactly what we're doing here. I see that on the first container, the water line stops at 150 milliliters. I'm going to write 150 on the line because that's my first amount. The next thing I'm writing is a plus sign. Total, we're adding, so we need a plus sign. Look carefully at that second container. I notice that the water stops halfway between 150 and 100. To get the amount of water in that container, we will need to find what number is halfway between 150 and 100. We can do this. I have my whiteboard here. The first thing I'm going to do is find what's the difference between 150 and 100. 150 minus 100. You should be able to do this in your head, but 150 minus 100 is 50. Great. Now we know how much is separating 100 and 150. We need to find what number comes halfway between there. To find that, we can split 50 into two pieces. So we ask ourselves, what number plus itself gives us 50? We're thinking back to second grade when Miss Hersey taught us about money. We know how to count by quarters. 25, 50, 75, 100. The number 25 comes halfway in between 0 and 50. So the water must stop at 125. Now that I know the capacity of the second container, I can add it to my equation and solve. In my equation, I have written 150 plus 125 equals question mark. Add carefully. My unknown is 275. Don't forget our label. 275 monkeys? No. 275 milliliters. And the way that we abbreviate it, we don't have to write out the full word every time. We write a lowercase m and an uppercase L. Milliliters. Folks, I am now going to give you time to solve problem number 2 on page 640. Problems 3 through 7 on page 641. When you get to page 642, stop and continue watching this video. There are some problems there I want to discuss with you. Friends, you should have finished pages 640 and 641. Now we're looking together at page 642. Problems 8, 9, 10, 11, and 13 are problems that you can do on your own. Problem number 12 is a challenge problem. We're going to do it together. Get your pencil and paper ready. Follow along as I read out loud. A cooking pot holds 1,000 milliliters of sauce. Then half of the sauce is used. Another 300 milliliters of sauce is added back in. Once again, half of the pot of sauce is used. Sounds like they have some tasty spaghetti for a crowd of people. How many milliliters of sauce is needed in order to fill the pot again? Notice this problem has a lot of steps, so we're going to take it slowly. What do we start with? The problem says a pot holds 1,000 milliliters of sauce. Then half of the sauce is used. What is half of 1,000? Let's use the trick where we cover up some of the zeros until we know our answer. If you don't know half of 1,000, what about half of 100? If you don't know half of 100, what about half of 10? This one we all know for sure. Half of 10 is 5. What about those two zeros? Don't forget to add them to the end. Half of 1,000 is 500. So now our pot has 500 milliliters of sauce. They used half, half stays in the pot. The next sentence says, another 300 milliliters of sauce is added back in. Added, that's a keyword that tells us, of course, to add. 500 plus 300. Use your mental math to get 800. The next sentence says, once again, half of the pot of sauce is used. Half of 1,000? No, we don't have 1,000 milliliters. We have 800 milliliters. Half of 800. Half of 800. If we don't know that, maybe we look at half of 80. Maybe we look at half of 8. What plus what is 8? 4 plus 4 is 8. So half of 800 must be 400. They use 400 milliliters of sauce. We have 400 milliliters left. The question at the end of the problem says, how many milliliters of sauce is needed in order to fill the pot again? How much did we start with? We started with 1,000 milliliters. We only have 400 right now. What do we need to add to 400 to get us to 1,000? Our equation might look something like this. 400 plus blank equals 1,000. We can flip this to subtraction to find the answer. You might already know it though. 1,000 minus 400 equals 600. 600 what's? 600 milliliters to fill our pot back up to the top. That was a tricky problem, but we handled it together. Friends, turn to the next pages in your packet. You will be doing pages 643 and 644 on your own. The problems that you'll be seeing here are exactly like the ones that we have done together. Make sure that you continue to use labels. Make sure that you do and show all of your work, your additions, your subtractions, your multiplications, or your divisions, whatever the problem is asking. You can do this work on some scratch paper if you have it. You can do this. You know how to solve capacity problems. As always, if you have questions about this, have your adult email me. If you are stuck, I'm checking my email every day to help you guys out. Keep working hard. Talk to you soon.